Hello, this is the video for section 12.4, Law of Sines. So what we're going to do in this section is we're going to find the area of a triangle using two sides and an inclusive angle. And we're also going to learn the law of sines, and we're going to use the law of sines to solve triangles. So let's first start with the area of a triangle. So we have this triangle, ABC. Okay, so the area of a triangle is 1/2 of the base times the height. So we make a height down from B to E, right? Down here, we make a triangle. They don't show you the triangle, but basically, let's draw this out. We have a triangle. Sorry. That was not really good. And we come down to make the height H. We form a right triangle. So to find the area, we can say we need H. Well, to find H, it's going to be what? Sine of A equals H over AB, segment AB, correct? Which is, we can call this little c, we can call this little b, and this little a, and this is capital C for angle. All right, so basically H over C is what our area is for this triangle, is our height. So, whoops. Let's go back one more to the first page. So here you go, triangle ABC. So H is your height. Remember, height and base have to be perpendicular for the area of a triangle. And basically, this equals C times sine of A, because this is what A is, and then we solve for H algebraically. We get H is C times sine of A, which we can put into our formula, substitute it for H, and we get the area equal 1/2 BC sine of A. So we can use this formula or two other formulas to find an area of a triangle that's not a right triangle, or that's not given the height, if we know lengths of two sides and the measure of an inclusive angle. So for instance here, we can come up with this key concept box, which you need to learn. So the area of this non-right triangle is going to be 1/2 times little b and little c times sine of A, the angle inclusive. And that's equal to 1/2 of little a times little c times sine of B. That's the inclusive angle. It's also equal to 1/2 of A times B times sine of C, because C is the inclusive angle between A and B. So let's look at example 1. They want us to find the area of triangle ABC to the nearest tenth. In the triangle, they said little a. So when we're talking about triangles, and we say that this is angle A, B, and C. So the side across that is going to be little a. The side across this is going to be little c. The side across this angle is going to be little b. So that's how we determine little a and little b. So they tell us little a, which is right here, is 8 centimeters, and b, this is the side segment AC is across from angle B, is 9 centimeters. And they tell us the inclusive angle is 104. So find the area. So now we have, remember, the area is 1/2, 9 times 8 times sine of 104. Now you need to make sure your calculator is in degrees, not radians. And then you just punch it in, and you should get, it's approximately 34.9 square centimeters, because we're talking about area. Okay, so now we're going to use the area formula to derive and see how they came up with the law of sines. So there was a lady named Pauline Sperry, if you want to read the history of law of sines, and it's right here to the left on your textbook. So the formula can be derived by, which shows a relationship between side lengths of a triangle and the sines of the angles opposite them. So for instance, here's our area formula. We had 3 of them. We said they're all equal to each other. So if we keep them as as an equation, two different equations, right? We can separate the first two and the second two, and then actually we can separate from 3 and put the last two equal to each other because they're all equal. So we just use our algebra multiplication/division rule of equation and say, let's divide the entire equation by ABC, which is the little ABC, which we're talking about the sides. So remember, we have to do it to every term. So when we do that and we simplify, the B's and C's cancel out here. So we're left with sine of angle A divided by A is equal to sine of B over B and the sine of C over C. This is what we call the law of sines, and that's what this key concept box is saying. And we're saying they're all equal. So when can we use the law of sines? So we use this when we're trying to find, in a triangle, you've got 3 sides and 3 angles. So when you're trying to find the missing angles or sides, you use the law of sines. When can you use them? If the measures of 2 angles and any side is given. So angle, angle, side, or angle, side, angle. It does not have to be an inclusive angle or inclusive side. It just has to be 2 angles and a side. You can also use it when the measure of 2 sides is given and the angle opposite one of the sides. Doesn't matter which one, as long as it's one of them. Now, when we use these given measures to find the rest of the unknown side lengths and measures, this is called solving a triangle. So let's look at example 2. So we want to solve triangle AB. So when you start this out, always start with your picture. I know mine's not perfect. We're going to pretend like it is. And we have 80 degrees, and we have B, and 3, and we have little a, and 45 degrees. So they gave us 2 angles. So we're missing the measure of angle A. We're missing little b, and we're missing little a. So first of all, identify what you're missing. Since we have 2 angles, how do we find the measure of angle A? So A is simply 180 minus 80 plus 45, correct? And what does that give us? It gives us 55 degrees. So measure of angle A is 55 degrees. Now, how do I find the measure of little b? Then we're talking about the side length. So remember, we have an angle on a side across, so we can say sine of 80 degrees divided by 3 is equal to sine of 45 degrees over b, because these two go together and these two together. We said this is our law of sines. So now we just do what? We do algebra. And then we divide by sine of 80 and divide by sine of 80, and we get b is approximately 2.2. Okay, so how do I find little a? So I'm going to change colors just so you can see. Sine of 45 degrees. Oh, I don't want sine, I want, what is a? So now we know that a is 55. We found that. So we want to find sine of 55 degrees. What's the side opposite? A, we don't know it, equals what was given, sine of 80 over 3. Now again, we're going to use algebra to solve. And all I'm doing is I did the cross butterfly method. So A is approximately 2.5. Okay, pretty simple, pretty straightforward. Just got to know the law of sines. So sine of angle A divided by the side opposite, which we call little a, is equal to the sine of B divided by the sine opposite, which we call little b, is also equal to the sine of C divided by the side opposite, which we call C. You can use any of these combinations to find your missing triangles. Now, that's when you're given two angles and a side. That's a no-brainer. Now, let's look when we're given the measure. So given the two angles and a side, there's exactly one triangle possible because we just subtract from 80, and that's the only thing that's left, whatever the degree is. So there's only one case. However, if we're given two sides and the angle opposite one of them, we have three possibilities. We either have 0 solutions, 1 solutions, or you have 0 triangles, 1 triangle, or 2 triangles are possible. We call this ambiguous case, another vocabulary word. So when we're solving for a triangle using SSA, we have 3 possible solutions. 0 solutions, 1 solution, or 2 solutions. So this key concept box is going to be really important, and it's going to tell us, it's going to give us all the information that we need to find the ambiguous case. So this only applies, doesn't apply when given two angles and a side. It applies when we're given two sides and an angle. And one of the angles, of course, has to be opposite one of the sides. So first of all, we have to consider a triangle in which A, B, and the measure of angle A are given. So we first decide the angle that's given, which we call A. Now, it might have a letter B, it might have a letter C. It does not matter. The angle that's given, we're going to use for formula purposes, is going to be considered the measure of angle A. If it's acute, we're going to look at the left side over here of this key concept box. If it's an obtuse or right, we're going to look at the right side of this box. Okay? So if A is acute, then we have to say, is it less than H? Is it equal to H? Is it greater than or equal to B? Or is it between B and H? And these are our possibilities. So you're saying, what is H? So remember, H is a height, and we learned that, excuse me, H can equal to B sine of A. So you're going to be given two sides and an angle opposite. The angle that's given is going to consider to be angle A, and that's what we look at for acute or obtuse or right. And the side across it is going to be little a. The other side given, whether it's called letters C, D, G, K, we're going to, for formula purposes for this box, is going to be side B. So in order to find H, we're going to do the other side given times sine of the angle to find H. And if A is less than H, there is no solution. If it's equal to H, there's one solution. And then we compare, is it less than A, less than B? Then you have two solutions or two cases. And then if it's greater than or equal to B, it's one solution. Likewise, if it's obtuse, we just compare A and B. If it's less than or equal to B, there's no solutions. And if it's greater than B, it's one solution. So if it's right or obtuse, there's only two cases, one solution or no solutions. Okay, so let's look at the first one. It says determine whether each triangle has no solution, one solution, or two solutions, and then solve the triangle. So they tell us in triangle RST. So let's draw this triangle. Okay, it's not a right triangle. It might look like it, but it's not. Okay, so T and 6, 105. Okay, so here they give us two sides and an angle. So we're going to say we were given angle R, and little r is 9, and we're given little s, which is 6. So it's obtuse, right? This is angle R. So we're either going to have one solution or no solution. So let's consider this is A, right, little a, and this is little b. Since A is greater than or equal is greater than B, we have one solution here. So we can solve using law of sine. So we can say sine of 105 divided by r is equal to sine. So now they want us to solve, since we know we have one solution, so we're missing what? So we need angle S, we need angle T, and we need little t. So sine of S over 6, and we can just use algebra. So r is going to be, let's see, 6 times sine of 105 divided by sine of 5, which equals 66. Oops, I did this wrong. Okay, so sine of S over 6. Okay, is equal to sine of 105 over 9. Oh, we knew 9. We're missing angle S. So we're finding the measure of angle S. So doing the algebra, we're going to do 6 sine of 105 divided by 9. And then we're going to do the inverse sine, because then we're going to have, what we're going to have is we're going to have sine of S, this is our theta, is equal to 0.64395. So in order to find theta S, excuse me, we're going to take the inverse sine, 0.64395. So you're going to do inverse sine of that value, and you're going to get, I did it wrong, but we're going to get that S is 105. Oh, we already know S is 105. Sorry. We're going to get it's 40 degrees. Okay. So this is 40 degrees. How do we find T? We're going to take 180 minus 40 plus 105 equals 35 degrees. Now we can use sine of 105 over 9, and we know that this is 35, equals sine of 35 over t. Using the algebra, t is going to equal to 5.3 approximately. Okay, so that's example number 3A. So let's look at 3B. So it sounds confusing, but you got to keep straight the formulas. So let's look at example 3. 3B. So they give you this triangle again. Okay, so they tell you triangle A, B, C. And we know A is 54 degrees. Oops, let me write this better. A is 54 degrees. B, A is 6, and little b is 8. Okay, so the first thing we need to look at is we're giving one angle on two sides, so we can have an ambiguous case, so we have to check for ambiguous cases. So we go back to our key concept box, and it says right here, so A is an acute angle, it's 54 degrees. So we're going to have one of these cases. So the first thing we have to identify is what is H. So we have to solve for H. So H is going to be the other side, 8 times sine of 54. When you do that, you get approximately H is 6.5. Okay. And what is A? So A in this case is 6. Remember, A is the side across the angle given, even though so that's what we have here. So since A is less than H, guess what? Let's look at our scenario. There's no solution. We can stop here. There's no solution. It's not a triangle. So if you use these sides, they won't make a triangle based on this angle, because you could use trig functions to find it. So we can stop there. Now let's look at example 3C. They give us, in triangle ABC, they tell us A is 35. They tell us little a is 17. And they tell us little b is 20. All right, so again, we're given two sides an angle. Check for ambiguous cases. A is acute, so we have to find h. So h is going to be 20 times sine of 35, which is approximately 11.5. So what is little a? So we said little a is 17, little b is 20, and capital A is 35. So A is greater than or equal to h. So we'll look at our cases. So it's not equal, so it's not this. So it's either going to be here or here, because we know A is greater than h. So now we have to check, is A greater than or equal to, A greater than or equal to B or less than B? So what is B? So B is 20. Since A is less than 20, less than B, and greater than h, we have two solutions. So we have to consider the acute angle and the obtuse angle. So the first thing is we're going to use law of sines, and we're going to look for this is we're given little b for the acute angle of angle B. So we're going to take sine of 35, which is given, divided by its side, equals sine of capital B over 20. When we do this and we solve, remember this is theta, so we have to use inverse sine. So again, we have to look for, we're looking for angle B, angle C, and little c. Okay, so these two are angles that we're looking for. So when we do this, we're going to get angle B is 42 degrees. Now to find C, we're going to take 180 minus 42 plus what was given, 35 degrees. When we do this, we're going to get C is 103 degrees. Now to find little c, we're going to take sine of 103 divided by c is going to equal to sine of A, which is 35 over 7. We always use what's given. And then we do cross multiplication and we get this is approximately 28.9 units. Okay, it's not degrees, these two are angles. So that's case 1. That's when B is acute. Now we need to find its obtuse. So we have to take B, the angle unknown, across from the side given. That's going to be angle B. So then we subtract that from 180 and we get, so again we have to find angle B, angle C, and little c. But now we're going to use 138 because we're going to take 180 minus 42. Okay, so we can find C, angle C, it's going to be 180 minus 138 plus 35. And when we do this math, we're going to get C is 7 degrees, tiny little angle. And if you look at the picture in the book, here's the second case, the obtuse case. Okay, now, so this is a solution 1. We're looking for solution 2, which is over here. I'm going to go ahead and use red. So now to find C, we take sine of what's given, 35 over 17 equals sine of 7 over C. Again, you use the butterfly method or whatever algebra method you want to use to find C, and we get C is approximately 3.6. So we have two sets of solution. The solution is here with the obtuse angle, and the solution is here with the acute angle. Okay, so we'll discuss more in class. Let's look at the Let's look at the word problem that we have here. It's a real world example 4. So it tells you a baseball is hit between second and third base and is caught at point B, as shown in the figure. How far away from second base was the ball caught? So we're given an angle here. Here's second base, there's third base, and the ball was hit here, and it was caught by the shortstop, it looks like, or the second baseman, actually, right here. So they want to find how far was it away from second base. So we're looking for this side here. So we're given, and we were told that this is 90 feet between second and third. So we're given side, angle, side. Because of that, we can find this side over here. So we need to find this angle, which is 72 degrees, right? Because we add 65 plus 43 and subtract 180 to get this, because now this angle is across from 90, which is given. So we're going to do sine of B divided by 90 is equal to sine of 43 over x, because this is what we're looking for. Now we just use the algebra. They use the butterfly method, and they solve for x, and x is approximately 64.5 feet. All right, do the homework problems, and we'll see you in class.